Alright, welcome to all things square root plus expressions. Now, number one is our standard transformation problem. It says a function f of x equals the square root of x is changed to become g of x equals negative 3x parentheses x plus 9 plus 4. And we want to describe the transformation. So let's just start with our negative. Ask yourself at this point, what does the negative do to the function when it's your a value? Well, we know that it reflects down. Okay? Now, next, let's take a look at our 3. Well, how would you describe 3? Remember, we're divorcing the 3 from the negative symbol. We only care about the 3, not the negative, just the 3. Is 3 bigger than 1? Is it less than 1? Well, here, when 3, or our a value, is greater than 1, we'll say it was vertically stretched. Alright, moving on. I look at the inside of my parentheses. I set my x plus 9 equal to 0. Of course, solving for x, I see that x is equal to negative 9. And we see that this was translated 9 units. And think about it, it's actually a negative 9, so 9 units left. And our very last thing, we have this plus 4. We know that it's going to go up 4. All right, well, that is our transformations. It's reflected down, vertically stretched, translated 9 units to the left, and up 4. All right, let's move on to example number 2. Okay, here we have which value of x makes the equation below true. And this is something that y'all just really excelled at. Of course, let's ask ourselves, should we get rid of the negative 3 or the plus 18 first? Well, of course we want to get rid of the plus 18. We always get rid of our addition or our subtraction first. And 6 minus 18 is negative 12. Is equal to negative 3 square roots of 3x minus 8. Well, remember, we always want to work to get our grouping, or in this case, aka our square root, by itself. This implies that we need to divide both sides by negative 3 to get rid of that. And negative 12 divided by negative 3 is equal to 4. Equals the square root of 3x minus 8. Now, from here, how in the world do you get rid of a square root? Well, all you have to do is square both sides. And I see here that 4 squared gives me 16, is equal to my square root and my square cancel, 3x minus 8. Well, when solving for x, we ask, do we get rid of the 3 or the minus 8? And here, to get rid of the minus 8, we have to add 8 to both sides. 16 plus 8 is 24, is equal to 3x. And we get rid of the 3 by dividing, and x equals 8. Alright? Hey, not too bad. Pause the video, finish taking notes. Let's move on to the trickier example. Okay, number 3 says solve for the values of x that make the function below true. So notice what's different about this is that inside the square root symbol, we have an x squared. So later on, this could make it a little bit more difficult. Well, we still want to get the square root symbol by itself. So we start by getting rid of our subtraction. So plus 3, and now we have the square root of x squared plus 6x is equal to 1 plus 3, which is, of course, 4. From here, how do you get rid of a square root? Well, we have to square both sides. And let's see what that gives me. My square root and my square cancel, and I have x squared plus 6x equals 4 squared is, of course, 16. Now, ask yourself at this point, whenever we see an x squared, whenever we know that we have an obvious quadratic, what do? Well, we want to set it equal to 0. So, we can subtract 16 from both sides. And let's write x squared plus 6x minus 16 is equal to 0. Now, from here, let's go ahead and try to factor it. Let's see here. Factor equals 0. And I know x squared splits up into x and x. And what two numbers multiply to be negative 16, but add up to be positive 6? Well, you can practice, you can try it out, but it would be positive 8 and negative 2. Because 8 minus 2 is 6, and 8 times negative 2 is negative 16. And of course, from here, we just set both of these equal to 0. We can write x plus 8 equals 0, and x minus 2 equals 0. Of course, how do you get rid of the plus 8? Minus 8 minus 8, x equals negative 8. And how do you get rid of the minus 2? Plus 2, and of course x equals 2. And here are my two solutions. Now, from this point moving forward, I would encourage you to pause the video, finish taking your notes. Let's move on to our example number 4. Okay, for example number 4, we want to simplify the expression shown below. Now, let's just go ahead and start with our distribution. Here we have 5x squared times negative 3x squared. And you always want to take this in parts. Say, what is 5 times negative 3? Well, that's negative 15. And x squared times x squared is really x to the power of 4. Remember, when multiplying your variables, you always add your exponents. Now 5x squared times 2, we have 5 times 2, which is of course 10. And x squared times x to the 1, which gives us x to the power of 3. We have 5x squared times negative 3, which will of course be negative 15x squared. Now notice in front of here we have a negative symbol, so that's like saying negative 1 times 3x to the 4. Well, we just write minus 3x to the 4. Remember, multiplying by negative 1 just changes the signs. So a negative times a negative is a positive 12x cubed, and a negative times a positive is a negative 8x squared. At this point, you want to combine everything that has the same letter and the same exponent. So I see this x to the 4 here, and I see this x to the 4 there. So I just add or combine my coefficients. Negative 15 minus 3 is negative 18x to the 4. I see my 10x to the 3. I see my 12x to the 3. Well, 10 plus 12 is 22x cubed. And right here I see my negative 15x squared and my negative 8x squared. Of course, this will be negative 23x squared. Oh, sorry, I meant to do that in a different color, but oh well, you get the idea. One more thing. Remember, when you're combining your like terms, you do not change the exponents. It's only when multiplying your variables together. All right, let's move on to example number 5. Okay, in example number 5, we want to simplify the expression below. So, let's go ahead and use our box method. We'll do 3 minus 7i. By the way, why are we using our box method? Well, I like to use it when I have two binomials. All right, so two sets of parentheses with two things or more inside them, and our 4 and our 6i. Well, here we have 4 times 3 is 12. In this box, we have 4 times negative 7, which is negative 28, and we tack on that I. All right, we have 6i times 3, which is 18i. And here's the tricky one that a lot of y'all miss. 6 times negative 7 is negative 42, but I times I is really I squared. Now remember, when working with complex numbers, I always want y'all to draw an arrow to the right, and I want you to rewrite this as negative 42 times, well, what is I squared? It's negative 1. Y'all have to memorize this. You have to memorize that I squared equals negative 1. And so that means that negative 42 I squared is really negative 42 times negative 1. That's a positive 42. So I can write this, 12 minus 28i plus 18i plus 42. See, I just drop it down. And I can, of course, combine 12 and positive 42 for 54, and negative 28i plus 18i is negative 10i. And there's your answer. All right, we got two more. Pause the video, finish taking notes. Let's move on. Okay, for problem 6, we have two more binomials. This time, though, notice we added some radicals. So let's go ahead and draw our box method. I would encourage you to try and make this one a little bit bigger because you have to fit in these radicals. Minus 3i square roots of 3. And here we have, of course, 5 plus 2i square roots of 3. Now in our top left box, we have 5 times 6, which is 30. In our top right box, we have 5 times negative 3, which is negative 15i square roots of 3. Here we have 2i times 6, which will be 12i square roots of 3. And here's where it gets a little bit tricky. Let's take it piece by piece. 2 times negative 3 is negative 6. I times I is I squared. And the square root of 3 times the square root of 3 is the square root of 9. Remember, for the square root of 3, that's a terrible square root of 3, times the square root of 3. It's really like saying the square root of 3 times 3, which of course is the square root of 9. Now, draw your arrow to the right, And let's write this out. Negative 6 times, what is I squared? Well, I squared is negative 1 times, what is the square root of 9? That's 3. Negative 6 times negative 1 is positive 6 times 3. 6 times 3 is 18. So at this point, let's write everything out. We have 30 minus 15i square roots of 3 plus 12i square roots of 3 plus 18. And of course, 30 plus 18 is 48, and negative 15 plus 12 is negative 3i square roots of 3. Remember, you can combine them because the square root of 3 and the square root of 3 are the same. Pause the video, finish taking your notes. Let's move on to our final example. All right, welcome to example 7, our final example. So here, we're going to go ahead and multiply these two binomials. And I want you all to notice something. This is 8 plus 2i square roots of 5, where that's positive. And here we have 8 minus 2i square roots of 5. And so this is actually going to be something fairly interesting. Let's take a look. 8 times 8 gives me 64. 8 times 2 gives me 16i square roots of 5. And negative 2i square roots of 5 times 8 gives me negative 16i square roots of 5. And taking this piece by piece, we have negative 2 times 2 is negative 4. I times I is I squared. And the square root of 5 times the square root of 5 is, of course, the square root of 25. And what do y'all notice that happens to our negative 16i square roots of 5 and our positive 16i square roots of 5? Because one is positive and one is negative, we can cancel them both out. So this means we have 64 plus, and let's go ahead and reduce this. Negative 4 times negative 1 because of the I squared. And the square root of 25 is 5. Well, negative 4 times negative 1 is positive 4 times 5. 4 times 5 is 20. It turns out that our final answer is 84. All right, and that concludes our year-long review. I hope that y'all watched all these videos, and I hope that you took all these notes. And good luck on your ACPs.